everyone. Thanks a lot for having me. My name is Paula. I'm a fourth year student at LSE in the macro group. So this is another macro paper. Sorry. So I promise this one is entirely empirical and very much focused on identification. So I hope that you will have helpful comments for me. Okay, so here I'm looking at the energy transition, especially because in macro, when we think about energy shocks, we almost entirely think about fossil fuels. And my proposition in this project is to look at electricity prices and exploit variation in renewables that change electricity prices over time. Okay, so allow me two slides to kind of motivate why we might care about this. First of all, electricity is becoming a more important share in production. I'm showing you data for Europe, which is where my project is based. So on the left, you can see total energy consumption has decreased recently and is projected to decrease even further up to 2050, while electricity consumption is actually projected to increase further. And on the right, you see the breakdown of that electricity consumption by where it's coming from. By 2050, it will be almost 90% renewable, and in Europe, a large share of this renewable electricity will be wind-based. And wind is what I'm going to be exploiting. So this just shows that there are several trends of replacing technologies, new industries emerging that are super data and electricity intensive, that are going to lead to a higher share of electricity in the economy. And in Europe, wind is an important driver of that. Secondly, this sort of move towards more electricity is quite asymmetric across sectors and maybe differentially so compared to fossil fuels. Okay, so here I'm showing you the energy intensity across different sectors in Europe. On the left, you can see that's heavily dominated by sectors like manufacturing, agriculture, or super energy intensive. Well, on the right, I'm showing you the share of total energy use, that's electricity within sectors. And that's much higher for the service-based sectors. So the highest one here will be information and communication, for example. So those tend to be the more growing sectors, and they're the more electricity intensive ones. This could be an important sort of phenomenon as we have some sectoral composition shifts and this increase in the importance of electricity. All right. So let me tell you what I'm doing in this project. As I said, macro shocks for energy are entirely fossil. Here I'm building one for electricity. So I'm thinking of this as a new source of a supply shock first, shifting the composition of energy shocks from fossil fuels to electricity, and looking at the different propagation of these kind of shocks motivated by how asymmetrically they're used across sectors in the economy. So the main question that motivates me is sort of what are the business cycle implications of this energy transition, looking at the shock specifically. And my main questions for today will be sort of how do electricity shocks have different effects from traditional fossil fuel-based energy shocks? And then how do they sort of affect sectors differentially? Are there different asymmetric effects that we're transitioning to as the electricity shocks become more important? So my approach in this paper is to construct a monthly electricity supply shock from wind speeds, and I'll show you exactly how I'm doing that, and using this as an instrument for electricity prices with a focus on Europe. And so I can use that to estimate effects of electricity price shocks currently at the macro level and some sectoral level. So currently this paper is entirely empirical, focused on identification. Yeah, I'll show you that. All right, so I'll give you a quick overview of some related literature. Oh, there's a question.
Can I ask you something?
Yes.
How are you going to square this thing that you're going to exploit this short-term monthly, I guess, exogenous variation with this ultimate goal that it's a bit more long-term outcome of business cycles, et cetera, et cetera? Do you have any thoughts on that?
Yeah. Yeah, I mean, that motivates me that in the long term, I think this is going to be much more important. Of course, for now, I'm looking at sort of medium-term effects of going there, but I think especially because electricity prices are more volatile and they are likely to become even more so, those are sort of long-term, well, I'm thinking of the business cycle in the long term, so medium-term developments over time changing.
Okay.
So that answers your question. Okay, so I'll show you quick literature, a little primer on electricity markets, because that's what I'm gonna be exploiting here. How I construct the supply shocks, and then some relatively simple aggregate and sectoral level results for now. Okay, so in terms of literature, as I said, energy shocks, macro, are 90% oil, 100% fossil. So the standard ones that you will have seen in basically any macro paper that uses the sort of energy shock or model that calibrates something with a cost push shock will use either an oil shock identified from a structural VAR with some assumptions on the oil market, or the more recent convened shocks that are based on OPEC announcements and using sort of news surprise effects. So here I'm contributing by giving you a renewable alternative that can be used for electricity prices specifically. Because oil is sometimes used in production of electricity, but of course used for many other things, so it's useless as an instrument for electricity prices. Of course, it's like not a new idea to use renewables as shifting the electricity price, but most of the literature in energy has focused on high frequency relationships. They're showing that with basically daily, hourly data, how renewable production and prices are related. What I'm going to be doing here is kind of use this variation for a macro instrument, and it's especially extracting the supply relevant variation in the wind, so that I can have a supply shock that's not related to demand, both in terms of electricity, but also general consumption patterns. And this is basically the first kind of instrument that we can use for electricity prices that's not based on a one-off shock or some regulatory thing, but we can use continuously in basically any place that has a significant share of wind electricity generation. That could be as low as 15%. There on basically works to do it like this.
Yes, the $10,000 question is how relevant this historical data will be for future energy production, because it's not only going to be wind, it's going to be other sources as well. Particularly, as you know, the discussion about using nuclear or other sources to even out those spikes that come from.
Yeah, exactly. Of course. So here I'm exploiting the role of wind as one very intermittent source. And as long as wind is one of the first sources that we use for electricity generation, it's not a problem for me that we then use other sources on top of it. It would be an issue if basically we move completely towards hydroelectricity, like in some of the Nordics is when it works super well, because there we have a very low share of wind. But for Europe, where all of the renewables are used first, I'll show you that in a second. I think this should still be useful even if we change the rest of the mix of electricity.
That's good. Clarify question. So I can imagine there being two kind of questions. One is, does the economy respond differently to an electricity shock of the same size as an oil shock? But or are the size, frequency, etc. of electricity shocks likely to be different than oil shocks? Are you doing one of them or are you doing both?
So today I'm going to compare the same size of shock in both of them. I think in sort of a next step, the interesting part is going to be that also electricity prices are more volatile than oil prices. And that's going to then play into this later on. For now, I'm doing like a unit-based comparison. We have 1 percentage point change in either of the price. Okay. There was another thought.
You said you would use wind so that you can identify a supply only stock, but what if demand is also going to be correlated? Maybe in high wind periods, we might use more.
Yeah. So this is the main challenge I'm trying to address with different identification strategies. So hopefully your question will be answered soon when I go through the details of them. But yeah, that's the main point I'm trying to make with the identification. I'm not just going to use the wind speeds. I'm going to do something to it to convince you that I'm not capturing demand effects. Right. So just as a quick primer, because this is what I'm going to be comparing to, you might not see this every day. So the main comparison is going to be the Penzig oil supply news shocks, which identifies from changes in oil futures prices around OPEC announcements. That's sort of the current exogenously identified oil shock. That's the standard to use. And he sticks that in another VAR model, and then he gets the expected sort of supply shock effects, an increase in the price and a more lagged decrease in activity for the US. Okay, so here's one way that electricity prices are different. Oil prices are inherently quite global, they're termed in the same currency mainly. Across Europe though, we have lots of variation in electricity prices. So here I'm showing you a snapshot from the beginning of last year, which is actually not a very extreme case. This is due to electricity markets in Europe being mostly nationally organized. There's trading across borders, but there's a unified price within bidding zones, which are almost always national. And there are some exceptions for subnational zones and some combined zones, but this is the general pattern. And prices at any time can vary quite a bit. Here we have like a factor of 2 difference, but it can go up to a factor of 5, 6, 7 difference, depending on what's going on in the different countries. And this is driven by one, which kind of like source mix do these countries use, but also how many renewables are they generating at a certain point in time. That's what I'm going to be exploiting. Okay, so why is wind useful for me? Because in wholesale electricity markets in Europe, we use the merit order pricing system, which means that we use the lowest marginal cost sources first to satisfy demand. The lowest marginal cost sources are always renewables. So when you have an increase in wind, which has marginal cost of almost 0, and that's how pricing is determined, just marginal cost, the entire sort of rest of the supply curve that's upward sloping will shift outwards. So wind has an inframarginal role for electricity prices in wholesale markets. So no matter what goes on basically with the rest of the supply curve, you're going to shift the entire thing. So here's an example in practice. This is Spain, also beginning of last year, where you see in blue the wind speeds of a day and then the wholesale price of the day. So what's quite striking is you see a clear negative relationship. So especially when wind is high, prices are really low. And within the day, they can go negative when you have a lot of wind generation. When wind is low, then the price is determined by any of these other sources, which have then be turned on basically to satisfy demand. Yeah.
Out of curiosity, would you exploit across sector differences in exposure to wholesale price variation? Or even across country variation in whether real-time pricing is applied to both household and firms? Like take the example of Spain, I think it's default real-time pricing, so there would be more exposed relative to say Germany, which is not.
Yeah, so this is one sort of heterogeneity across countries that for now I'm actually not exploiting directly, but I agree that it's a big factor in terms of like pass through from wholesale to retail prices, both for households and firms, which varies quite a bit. So my main results are going to be like an average across Euro area countries, but by country they do vary quite a bit, especially because of that. So that's wholesale markets. Here I'm just showing you the retail exactly like you asked. This is basically the average of across countries. What we can tell, unfortunately, we don't have great data. So this is not because it's sticky prices, it's biannual data that I'm showing you. But what we know is that firm prices move more closely with wholesale prices, and more so the higher their consumption is. Okay, so there will be some firms that directly take part in the wholesale market and actually pay those prices. For others, they will have longer contracts, and prices will only be a part of, wholesale price will only be a part of the cost that they pay. But we kind of see that they do move with wholesale prices. They're still around a third of the component of the actual cost that you pay as a firm or a household. So this is the data that I'm using. The important part is my sample is 11 Euro area countries, and it starts in 2015. This is one, a data limitation on prices, and two, a thing of we need enough wind installed capacity in order for this to have any power. So I'm not sure how far I could extend it going backwards. The power of the instrument basically increases over time as we install more wind capacity. And yeah, the other interesting part of the data, I guess, is that I'm going to be using some spatial data on the location of wind turbines across Europe, and then some ERA5 weather data, basically on wind across grid cells that are 28 kilometers square. Great. So this is the main part of my contribution, shock identification. How do I do that? This paper has gone through a bunch of iterations. This is my current preferred version, and I'll have some now robustness checks to show you different versions of the shock. Okay, this is the spatial identification. So here I'm showing you all of the wind turbine locations across Europe that have a capacity of more than 10 megawatts. So all of the farms basically, and this is a snapshot from beginning of this year. And what I'm gonna be doing is overlaying that with wind speeds in the locations of these farms, varying over time. Okay, so my strategy to identify the shock is basically to say, let me pick all of the grid cells in which we have installed capacity for wind electricity generation, weight them by how much capacity is installed in one grid cell versus the other, and then compute the average wind in a certain month across these grid cells. Okay, so I'm creating a weighted measure of wind where generation is installed. And then in order to make sure that I have a question.
Is there a lot of entry? Does that matter? Turbines are excluded?
There is quite a bit of entry. So right now, the data I'm using to the turbines is OpenStreetMap, which is not perfect. So
Also endogenous where they're going to be picked up, right?
yeah, so it seems, so I have some official data sources by country, so I can see that it seems to be relatively correct, but this is why I'm also using current locations of wind turbines, because the further back I go in that data, the less reliable it sort of is.
Would it matter for your identification strategy if there was not picked up in the data entry of wind turbines according to some?
I think if I'm missing some, then that goes against me, so that probably wouldn't be so bad. So what I'm doing here is then I'm actually controlling for wind in all of the grid cells where I don't see a wind turbine installed. So I would basically be reducing the difference that I'm using here. Okay, so the shock that I'm actually using as an instrument is basically the excess wind in places where there's installed wind turbines weighted by their capacity compared to everywhere else in the country. So if there are some more stuck in other places that I'm not capturing, I think that would go against me rather than help me in this situation.
Yes, I don't know, maybe we should be serious, but like, what if the wind turbines are installed in places with high prices in response to?
So here, yeah, this would be a concern for a small subset of the countries that have bidding zones that are not national but subnational. So in most of the countries that are in my sample, the bidding zone is entirely national, so the price is actually unified. So if I live in the north and there's a lot of wind turbines, or I live in the south and there are none, I'm benefiting the same way. So the exception in my sample, the big one would be Italy, where they're quite segmented in terms of bidding zones, but in the other countries, that's actually not a concern because prices are unified.
I mean, Sweden is extreme for different zones and huge differences in prices, but there's very little of a wind turbine response because it's a highly politicized process how you construct these things. So it's
Yeah.
I'm not sure it
Yeah,
matters.
yeah. Thanks.
Because even with a unified price within a national market, you still have local factor markets, and so there's still maybe some kind of interaction with, building a wind turbine where every single other person is building a wind turbine because they've taken up all the land.
Yeah.
Does that matter? Or?
Yeah, I'm thinking how that would matter for sort of the retail price that comes out of this. I think it might matter for the rest of the cost share that's not linked to the wholesale price. I'm not sure how I would incorporate that, but I think for the wholesale price, it should be up.
It's just that the net price, net of local factor costs it's not uniform conceptually there, but then I don't know for estimation if it matters.
Yeah, okay, thank you.
Good question on the excess wind. We've had news at some point that the wind was so strong that the wind turbines were not operated at all. Do you need to bind it at some point? Because that excess wind is great in some moments, but at some point it's just too much.
Yeah. So I didn't put it here, but I actually capped so basically I have missing observations whenever wind is more than 90 kilometers per hour though, because when I looked into this, the turbines are actually remarkably stable. So it really needs to be a big storm for them to basically incur damage. So the cut in, cut out range for operating is quite large. So I don't have a lot of those instances at least, but yeah, you're right. Yeah, okay. So I use this weighted turbine capacity wind. I control for wind elsewhere. I go for seasonal fixed effects, because that's something I don't want to pick up. And then the residual is the shock measure that I'm using. So I'm then relatively confident that this is not capturing demand effects. Also because most of the wind turbines are installed in places where there's not a lot of population, right? So I'm really capturing differences in wind across space that will be more relevant for supply rather than demand. Right, so this is what it looks like. These are wind shocks by country and a year area average. What should this look like? Well, it's a shock, so this is what it is. Basically, this is a good picture for a shock construction. It looks erratic. There's no clear pattern between countries or anything like that. This is what we want. Okay, I'm happy with this picture. And then here's the first stage results. I'm using the shock to instrument for changes in electricity prices month on month. Okay, and I do this by country, but the main sort of results I'm going to show you using a panel of countries. Yeah, this works relatively well for most of the countries in my sample, and especially well if I also exploit the cross-sectional variation across countries in a sample. So that's a relatively strong statistics there. Do you have a question?
Yeah, did you also do that for retail prices? Because I think, well, strong F statistics is, yeah. I don't know, I would be interested in the F statistic if you do it for retail prices.
I would too. Unfortunately, I only have them at biannual frequency.
Yeah.
I'm assuming that the lag will be much longer, so I probably wouldn't do it for monthly changes. I would have to do it for like year on year, things like that. But I do see relatively persistent changes in price levels, so that encourages me that there is some pass through, that it is still relevant for retail price. Okay, here's basically the now robustness checks. You can do this in several different ways with national data. My main message is all of these yield positively correlated shocks with the one I just showed you, and encouragingly similar, at least qualitatively very similar results to what I'm going to show you with the wind turbine capacity shock. So that's encouraging to me. Okay, here are the shocks there. Told you what do we want to look out for. We don't want them to be heavily serially correlated. They are at one lag, so that's what I'm going to include whenever I put them in a regression. And I fail to forecast them with any sort of standard variable. These are the things to look out for. Here's what this looks like compared to the oil supply news shocks, which would be the current standard, the Kensick one. There's a small negative correlation. It's insignificant. It doesn't seem like OPEC is responding to wind shocks at this point. Who knows, maybe that will change, but I'm relatively confident we're capturing something very different.
Sorry, on forecastability,
Yes.
is it about standard macro variables or, I don't know, climatological variables that might also be available and used where it's relevant?
Yeah, so one of the sort of national data shocks I've constructed is using either different climate variables to control for. So think of what would I expect wind to be and take the sort of surprise in that. And that gives me relatively similar results. Yeah, if you have suggestions how I can try to like forecast this, I would be interested, but yeah. I don't know, I'm relatively confident that it's okay. All right. Yes.
For other shocks, I mean, there's the other Diego Kensick's paper looking at the EU ETS futures, doing the same setup. You would imagine that a large enough wind supply shock could affect either supply or demand of the carbon credits, right, traded on the EU ETS. So is that a concern that there could be some pass through the carbon price and not directly through the supplier price of electricity?
Yeah, I think that's an interesting idea. I have to check that, whether I actually get some significant response in carbon prices to these shocks. I guess there are more aggregates and these are more local shocks, so I don't know how large it would be if I just get an isolated country-wise. But yeah, I can check that. Thank you. Okay, let me show you some aggregate results. So here's the main specification I'm going to use. It's fairly standard, so I'm just using a local projection with an external instrument. I'm going to be instrumenting for changes in energy prices one, the change in electricity wholesale prices, like I've shown on the first stage with my shock measure, and then to compare oil prices instrumented with the Kensick shock. And here I'm giving the Kensick shock a bit of country variation by multiplying it with the pre-sample energy weights in HICP. So I sort of compare the same thing. It's not an unfair comparison. I always control to lags, monetary and fiscal policy responses, because I'm going to show you an average over a relatively short time series sample. I have to sort of control for all of these things. I include a COVID dummy. I can also include even time fixed effects, but it doesn't make a big difference between the two. Okay, so here's the main results. First of all, as we would kind of expect for a supply shock, the general price level increases. Actually, it was not a significant lag. It's barely significant, but the disclaimer, I'm at least showing you 90% confidence intervals. Normally an LP paper might show you 68, you have to look very carefully. But we can be very confident because I've chosen the local projection as opposed to a VAR that the effect is within here. So we have an increase in the price level. The maximum was about 4 basis points for a 1 percentage point change in the price. That's slightly more than the weight of electricity in HICP. And then it sort of fades out over time. That looks quite different across countries. So this is an average because of the different pass-through across space.
It's not very related, but I was wondering, for countries with multiple bidding zones, could you use regional variation in transmission constraints? Say in Italy, in some places, the impacts of wind on prices really vary, it's very local. And you have municipality economic variables in Italy.
Yeah, I can test that for sure. For the case of Italy, I could do a test of this. Yeah, thanks. Yeah.
I find the general production fairly surprising.
Yes.
Usually it's a demand induced price.
Let me get there. So the price response is what you would expect. The activity response isn't. By classic supply shock, you would expect economic activity to be depressed, like in the Kensick paper. So yeah, here, if anything, we get an increase in industrial production. We get a non-negative response of GDP. We get little going on with the unemployment rate. So my first check was, let's do this for oil prices for the same sample. Because we're looking at a different economy, we're looking at a different sample. What kind of effects did they have? They also increased prices higher according to the entire share of energy in HICP. It's actually more lag, no surprise on that. But on the activity results, this is actually not so different. Most of this is driven, so what if I do like subsamples, most of this is driven by the last 5 years. If I do the same thing for 2000 to 2010, which I can do with the oil shocks, it looks much more like the classic thing you would expect. You have a little hump shape and then activity depressing over time. So this seems to be something general that's been going on about energy, not just electricity. Although there are some differences, especially when you look at the unemployment rate. So if there's an energy shock, it seems to be that there's more of a sort of substitution towards labor unemployment actually decreased. Let me skip. Here's just to say, what are these sort of results driven by? Mostly, they're driven by increases in electricity prices, as we would expect. Decreases in prices are rarely passed through. So all of the significant responses come from an increase in the price. And also they're driven by the larger shocks. Okay, the larger shocks are the ones that give me a significant response of both prices and industrial production. And actually a relatively significant initial spike in industrial production. Maybe that's driven by sort of firms that are front loading their production until their contract adjusts to different electricity prices. All right. Lastly, I want to show you some sectoral effects. I'm going to sort of go through this super quickly. I mean, thing is that based on energy consumption within a sector, there are some differences with respect to price responses across sectors. In terms of gross value added, which is what I have at sectoral level at this point, it's not so clear. Oil shocks are actually remarkably symmetric across sectors, whereas electricity shocks not so much. So let me wrap up. So I have an intro result. I hope I could convince you that wind is a relevant supply shock to use for electricity price changes to study causal effects of them. Yeah, and what I'm hoping to do next, basically go more into the mechanisms of the differences to oil. What happens if we really switch more of the use, but also generation towards these wind electricity shocks? All of the differences in global versus regional pricing, different trade-offs that they imply, different pass-through to prices and these regional. Thank you.